All right, Math 8 students, here we are, lesson 12.1, the Pythagorean Theorem. So this is to accompany some of the reference sheet and example questions that we did in class today. And then we're going to take a look a little bit deeper with your Explore activities in this lesson. So first, Explore activity proving the Pythagorean Theorem. So in a right triangle, two sides that form right angles are the legs. The opposite sides of the right angle is the hypotenuse. So the long side, that is your hypotenuse, and then the short sides that form the right angle, those are the legs. In a right angle, the sum of the squares of the lengths of the legs is equal to the square of the lengths of the hypotenuse. If A and B are legs and C is the hypotenuse, then A squared plus B squared equals C squared. So that's saying we have A, B, and C, and so we take A squared plus B squared equals C squared. So the length of A squared plus the length of B squared equals the length of C squared. And so we can solve for any missing length given that we have two of these measurements. So what they want us to do is draw a right triangle on a piece of paper and cut it out. Make one leg shorter than the other. Trace your triangle onto another piece of paper 4 times, arranging them as shown. For each triangle, label the shorter leg A and the longer leg B, and the hypotenuse C. So we're going to go ahead and use their diagram here. We're going to label all of our short legs A. So we're looking at these shaded in triangles here, right? All of those short legs A. We're going to label all of our long legs B. Right? And then we're going to label our hypotenuse C. Now it wants us to find out what is the area of the unshaded square. So this square right here, remember area of a square is base times height. And if it's a square, it's actually just the length squared, right? So in this case, that would be C times C, or C squared. And it might want us to use our square units, so that would be C squared units squared, depending on what our units are, right? Label the unshaded square with its area, C squared. And then what does it want us to do? Trace your original triangle onto a piece of paper 4 times, again, arranging them as shown. Draw a line outlining a larger square that is the same size as the figure you made. So this is the figure we made in B. It wants to do the same size here. And then it wants us to determine the area of the unshaded square at the top right of the figure. Okay. Well, this is A, B, C, so that means that this is also B, and this is A. This is a square. They told us that. So this would be A times A, or A squared. And at the top left, well, this is A, B, C. This would be short leg A and B. So that means that this is also B, since this is a square. So our area would be B squared. Okay, then label the unshaded squares with the area, and we already did that. A squared and B squared. Got those lengths from our triangle lengths here. Okay. And then it might want us to write unit square or squared units, just to make sure we're using the proper notation. So units square, or you could write squared units. That'd be okay too, or square unit. So what would the total area of the unshaded regions in D be? Well, that would be A squared, the area of A squared, plus the area of B squared. What we're getting at here, we're starting to put together Pythagorean theorem. Let's go ahead and move to this next page here. So reflect. Explain whether the figures in B and D have the same area. So let's take a look back here. Figures in B and D. So figure in B, the area is C squared. Figures in D, it's B squared plus A squared. But we're looking at side length, right? So the area of the triangles hasn't changed, which means the area of the unshaded squares has not changed, because this these dimensions, this outer dimensions are also the same stuff, right? So we just rearranged our shapes within there, which means that the area has not changed. We haven't changed the shape, we just rearranged the figures inside. So yes, the outlines of the figures are the same size. The same size. Explain whether the unshaded region in figures B and D have the same area. Yes, they have the same area. Because the shaded regions have the same area because subtracting those shaded regions still gives you the same unshaded region, right? The area, the overall area has not changed. We've just rearranged the figures, right? Area has not changed. From B to E, we simply arranged the figures. Let's say shaded and unshaded figures. Which means the area would be the same for each one. So then we're going to analyze our relationship. Write the equation relating to the area of the unshaded region in step B to the unshaded region in D. And so that was C squared, right, for B, which means that's going to equal the same thing as A squared plus B squared. So the area in the second figure configuration is equal to the area in the first configuration. So this right here is Pythagorean theorem, and if we look back here, this is how we know that we can use Pythagorean theorem to solve for missing side lengths, because the area does not change when we configure all these triangles together. So that lets us use that to solve for missing side lengths of triangles. So now we're going to look at this example here that's going to walk us through the steps of using Pythagorean theorem, and we already did a little bit of this in class, so this might be a review, but that's okay. So if we have a triangle that's got two side lengths, we're trying to solve for C, right? So this would be A, this would be B, and this would just be C. So we're going to plug those values into our equation here. A squared plus B squared equals C squared. And I just did mine backwards here. You could do A and B, that would be fine. It's going to result in the same answer. So we substituted into the formula. We have 24 squared plus 7 squared equals C squared. 24 squared is 576, and 7 squared is 49. We're going to add those up, and we get 625. So 625 equals C squared. Now we need to take the square root, and this is where we find a common error, right? So we have 625 equals C squared. Oops. C squared. The opposite of squaring something is finding the square root. So we're still kind of using that inverse operation to solve. This is going to cancel that out and leave us with just C. Finding the square root of 625, what number times itself, not this number divided by 2, but what number times itself gives you 625? And that is 25. So use calculators if you needed to find that square root, especially if there's some of the bigger numbers, but you want to start kind of memorizing what our common square roots are, especially our perfect squares. So let's take a look at B. The length of the hypotenuse is 25 inches. So this is our C here. One of the legs is 12 centimeters. Oh, centimeters, not inches. And the other leg is our unknown, okay? So we're going to solve for A squared. Well, not A squared, just A. And this is going to be B. And we're going to go ahead and plug those into our formula. So we plug 12 into B and 15 into C. So let's go ahead and solve here. We've got A squared, which doesn't change, B squared, which is 12 squared. 12 times 12 is 144. and then 15 squared, which is 225, 15 times 15. So then we've got a squared plus 144 equals 225. Now we're going to use inverse operations here to get the variable by itself, so minus 144. And we get a squared equals 81. So then we need to find the square root of a squared and the square root of 81, right? So again, square root, square root, square root. And that is not what number times 2 equals 81, it's what number times itself equals 81, right? So 9 times 9 is 81, so a equals 9. And that's our solution. Make sure you're putting that back into an answer with the appropriate units, which I didn't mention up here. So make sure you're using those appropriate units. Let's take a look at this little math talk for a second. If you were given the length of the hypotenuse and one leg, does it matter whether you solve for A or B? What do you think? Does it matter whether you solve for A or B? It doesn't actually. Some people like to always identify A as the short leg and B as the long leg, and that's going to kind of just come down to really what material you're working with at any time. It doesn't matter though, because the length of the leg can be substituted for A or B, right? Because we don't know if it's the long leg or the short leg all the time. So no, the length of the leg can be substituted for either. For either A or B. Since they both represent lengths of legs. Okay, let's go ahead, and I think we've got some your turn questions next. Yes, we do. So we need to find the length of the missing leg. So I'm going to write our formula right up here. A squared plus B squared equals C squared. And that's the formula we're going to make sure that we need to plug our values into. So looking at number 4, we've got, I'm going to go ahead and call this A, I'm going to call this B, and then our hypotenuse will be C. So we're solving for our hypotenuse here. So we are going to plug these into our formula. So we've got 30 squared plus 40 squared equals C squared, okay? So 30 squared is going to be 30 times 30, which is 900. 40 squared is going to be 40 times 40, oops, it should be plus. It's going to be 1600, and then we have C squared. So we need to solve for C, so we're going to combine these two. So we've got 1600 plus 900, and we get 2500. So this is just like an example you had on that note sheet that I gave you guys earlier. Oops. Equals C squared. Okay, and to solve, we need to find the square root of 2500. And you can use your little square root button. But if you think about this, well, what's the square root of 25? That's 5. We've got some zeros here we need to factor in. So your square root would be 50. And then our units are feet. So I'm going to write my answer down here. Oops. 50 feet. C equals. And that makes sense too, because this should be the longest leg. So it makes sense that this is longer than both of these legs. That's just kind of just a quick double check there. Okay, now we've got our second your turn, number 5. And we've got our hypotenuse, so this is C, and I'm going to call this one B, then I'll call this one A because I like calling the short leg A. Okay, we're going to plug that into our formula, A squared plus B squared equals C squared. And I'm going to plug in A, which we don't know, so I'm going to leave that as A squared. And I'll plug in B, which is 40 squared, and then plug in C, which is 41 squared. So A squared remains unknown. I'm going to square 40. 40 times 40 is 1600 equals 41 squared, which is 1681. And then I have to use my inverse operations to solve, right? So I've got to subtract 1600 because I'm trying to get that variable by itself. Cancels out here, and I have a squared equals 81. Okay? So I need to find the square root of 81 to find a. And so what times itself equals 81? And that's just from memory that I know that 9 times 9 is 81. So my answer is 9 equals a. And then I need to make sure I put my units back in there. So a equals 90 inches. Sorry, 9 inches. A equals 9 inches. All right, so I'm going to go ahead and stop here for now, and then we'll go ahead and take a look at example 2 in the next video. And so if you need help with that one, skip forward to that one. If you are feeling pretty good, then go ahead and start on your guided practice and your independent practice. If you have questions, bring them to class so we can talk about them together and go over them if you need help. All right, I'll see you in the flip side.